Okay, so one of the things I want to make a couple of comments here. And number one is that, for continuous groups, we differentiate say between U1, which is isomorphic to SO2, and say R1, say which is isomorphic to SO1, 1. Okay. In other words, the topology of the parameter manifold plays an important role. All right. So this motivates the next definition, which is the definition of a Lie group. Okay. So so far we've actually been discussing Lie groups. So a Lie group is a group whose parameter space is a manifold. Another way of saying is that a Lie group is a group which is also a manifold. So for example, number one, SO1, 1 is a Lie group because its parameter space is R1. Okay, number two, U1 is a manifold because its parameter space is a circle. Okay. So naturally, so we have met, of the groups that we've met, the natural question is, what is the manifold? That corresponds to SO3. Okay. So that's the next question. Before we answer that questions, are there any questions?
Sir, how is the parameter space S1? Like, isn't like the space from the interval 0 to 2 pi?
Yeah.
I mean a segment of the real line. So can that
so yeah,
be
we are
written?
identifying 0 and 2 pi for SU2 for U1.
Oh, okay.
We are identifying the points, endpoints, right? For the phases, right? So this is e to the power I theta. So this is 0, theta equals to 0, but this is also 2 pi. That's why it's an S1. Okay, so any other questions or comments? So I want to understand, so we want to understand what is the manifold of SO3. So what do you think is dimension of this manifold?
2, or no, 3.
Why is it 3?
We come to it from the dimensions of O3.
Right. Because we counted the parameters, right?
Yes.
Yeah, and there are 3 rotations, independent rotations.